right.
Okay. Let's take a look at, let's see, your first one was number 7.
Yes.
And am I on the right page? Yeah. So number 7 was f of x is equal to 6 minus x squared. And g of x is equal to x times the square root of x plus 10. And the instructions say we want to find each one of these values.
Okay.
Now there's different ways you can do this. And I'll show you the easiest way when working with numbers. What this means is g of f of 0. This is a composition symbol. This actually is a composition of g and f. But you can think of this is O, g of f. That's an easy way to remember how to rewrite it. Now we're going to start with what's inside here. So we'll find f of 0. So over here on the side, f of 0, this is just evaluating this function. I'll put 0 in everywhere I have an x, which then gives us 6.
Okay.
So then I can replace the f of 0 with 6.
Yeah.
And then we're going to find g of 6, so we're going to go to our g of x, and I'll put 6 in everywhere we have an x. So I have 6 square root of 6 plus 10. And 6 plus 10 is 16. And 16 is 4 times 4. We're looking for a pair of somethings with our square root, so I'll bring that out. And that gives me 6 times 4, or 24. And that's
Okay.
our answer.
Okay. It's pretty straightforward. No, Professor, what exactly is this used for? Like, is it for graphing? So you can graph.
This is an example I always give in class. You'll have to forgive the artwork. Okay. Now, little fish eat plankton, eat eat bugs or whatever, and big fish eat little fish, in theory. And I can come up with an equation that tells us how many plankton plants do we need, or how many bugs do we need to support these small fish. For example, if I want 3 small ones, then I put 3 in for x. 3 times 3 is 9, minus 1 is 8. So I need 8 of these. Now I can also find some kind of equation that ties these together. So if I want 1 big fish, I put 1 in for x. 20 times 1 is 20, plus 1 is 21. That means I need 21 small fish to support that big fish. Maybe what we're really interested in is this right here. How many bugs, how many plankton plants do I need to support my big fish? Even though they don't eat on it directly, it's part of the ecosystem. Or maybe I want to know how many big fish I need to keep these going. So this, what we're finding right here, this is the composition of functions, and that's what this entails.
I see. Okay.
And you can get these equations here on your calculator. There's a linear regression function that will give those to you based upon sample data points.
Okay. All right. I get it.
Okay.
Cool.
let's see, part B on that. F of g of -1. Actually, I may erase the fish drawing. Now this, again, we rewrite as f of g of -1. And then we work with the inner first. So I'll take a look at the g of -1. So I'm going to plug -1 in everywhere I have an x. So I got -1 times the square root of -1 plus 10. -1 plus 10 is 9. And square root of 9 is 3. So that gives us -3. So then we come back over here, and we're going to replace the g of -1 with -3. And now we're finding f of -3. So I'm going to go to my f of x, and everywhere I have an x, I'll put in -3. Now I'll go ahead and put parentheses here since there's negatives involved. Everything else remains exactly the same. 6 minus, the minus here, the second power. I just replace the x's with parentheses. And then I'll plug in my -3. Now negative parentheses negative becomes a positive. Minus. -3 squared is 9. So then 6 plus 3 is 9. 9 minus 9 gives us 0.
Okay.
And that'd be our answer.
All right, I think I get the gist of it now. I mean,
Okay.
We're just solving for one equation, plugging in what we solved, what the answer was for that equation into the next one. All right, I get.
Okay.
I understand.
Let me clear this off, and we'll look at number 44. It's kind of the same idea, but it's a little bit different. Okay, so we got f is equal to -3, 4, -2, 2, -1, 0, 0, 1, 1, 3, 2, 4, and 3, -1. And G, -3, -2, -2, 0, -1, -4. I wouldn't write this down if it wasn't so important to understand the points.
Mhm.
0, 0, 1, -3, 2, 1, and 3, 2. Okay, 44, we want a composition of f and g, and then we're at 3 there. Now remember what this looks like. This is f of g of 3. Now we're still going to work with the inner one. So I'm going to write that over on the side here. So we got g of 3 is equal to something. Now whatever's inside of your parentheses is always your x. So they're telling us that x is equal to 3. And this other side is always your y.
So 2.
Exactly. Yeah, because we're looking for a point that starts at 3, which is like there, and like you point out, it's a 2 there. So that's going to equal to 2. So then we come back over here, and this is f of 2.
Okay.
And then we look up the, again, whatever they give you inside parentheses your x, so they're telling us x is 2. And if I come over here, then our y is going to equal to 4.
Okay. What if it was given some coordinate that doesn't like -4, or like f of g of -4, and there's no -4 for g, it would just be undefined?
Yeah. Yeah, since it isn't in the domain, then it would be undefined.
Okay. Okay. All right. That's
Okay.
that is similar vein. Um. All right. I
Does
get it.
that make sense?
Yeah. Yeah.
Okay.
What about 46? Like f of 0.
Oops. 46. F of 0. Now, even though it seems weird, remember that's just f of 0,
Oh.
and we're working with the inner. So f of 0 over here, again, what's inside the parentheses is always your x, so telling us x is 0. So when we go and look, looks like that's 1.
Mhm.
So then this gets replaced by 1.
Okay.
And then f of 1, where's 1 at? That'd be equal to 3.
Okay. Oh, interesting. All right. What about, Professor? What about number 55, which is like g of n times of g of 0?
55.
0. This seems like interesting.
Oh, that's
It's
interesting. Yeah, let's take a look at that. And
the other points are 1 minus 3, 2, 1, 3, 2.
1 minus 3. What's the next one?
2, 1,
2, 1,
3, 2.
and 3, 2. Okay. And number 55, G, and then a bunch of them.
Yeah.
I don't think I've ever seen one like this.
It's neat.
Now, regardless, no matter how we set it up, this would be like G of so on until your first one there and is G of 0. Well, if I look at that one there, G of 0 would equal 0.
Oh, okay. So it's just all right.
Yeah.
0, 0, 0, 0. So that's
Right.
maybe.
So eventually it would just give you 0.
0. Okay. Well, is it possible to like see if it would go back and forth? It was like 0, 1, 1, 0 or something like that, and it would go back and forth depending if it was like an even.
It would exactly. You'd have to know whether it's even or odd, the number of occurrences.
Okay. All right. That's neat. Okay, that's pretty. So.
Let's see. And then you were asking about 56. Now, I'm not going to be able to draw that very well, so I'll flip over and refer to the picture.
Okay.
So 56 is G of F of 1. Again, same idea. We're going to focus on what's inside the parentheses. So we want to find f of 1 is equal to something. Whatever's inside your parentheses, your x, and then the other side is a y. So we're looking for a point on our graph that's 1 comma something. That's specifically on the f of x graph. So 1 comma something, well, that'd be this one right here. This point would be 1, 2.
Okay.
So if I go back over here, again, the only thing we're wanting is the y part. So then this becomes G of 2. And G of 2, remember whatever's inside your parentheses, your x, so they're telling us x is equal to 2. And whatever's on the other side is our y. So we're looking for a point on a graph that's 2 comma something. And specifically, we're looking at the G graph now. So over here, this point right here would be
2, 2, 3.
2, 3.
I think so. Yeah.
Yeah, it almost looks like it's a little off, but my eyes are just probably thinking about
That's
it too much. Yeah, and then I'd give you 3.
okay. All right. That's also
Okay.
similar to looking for points. All right. So I get those now. What about 5.2? Professor, you teach many classes. I see from your YouTube channel.
Yeah, I teach quite a bit.
Do you teach at the same place, or do you teach at many different institutions?
Different institutions. I'd like to stay busy,
That's good.
but I'm full time at one particular institution, Cali.
Oh, Cali, like as in California, or as in?
No, it's in Kansas, Cali County Community College.
Oh, cool.
So
I,
Cowley.
oh, all right. Very cool.
Now here, we got f of x is equal to 6x minus 2. Now our official definition of a one-to-one function, this is just going to be a shortened version of it, but it says for a one-to-one function, for every x there is only one y, and for every y there is only one x. Now an easier definition says that if you have one of the following, it is not a one-to-one function. X to an even power, y to an even power, now this covers most of the items you run across in algebra books. This is definitely not covering all the different cases. Absolute value of x, absolute value of y, the plus or minus symbol, then x is equal to a number or y is equal to a number. Now it would be like if you specifically had x equals 3 or y is equal to 5, and so forth. Unless there is a condition put on x. Example that, we got y is equal to x squared. Normally that would not be a one-to-one function, but if we put a condition saying where x is greater than or equal to 0,
Okay.
then that makes it a one-to-one function.
I see, because then it's only on the right side of the Cartesian plane.
Exactly. Now where that comes in is that if you're what you're working with, your problem is not a one-to-one function, then it doesn't have an inverse, and you shouldn't even try to find it.
Okay.
Now see how these ones down here have x squareds in them?
Mm-hmm.
But all of them have conditions put on them. They put those conditions on there so that it will have a an inverse.
So you have to find like the vertex of, or would the vertex of the function be?
It corresponds to the vertex exactly.
Okay.
Well, I shouldn't say it will always, but I think you'll find in every algebra book that's what it will do.
Okay.
Okay, so show that the given function is one-to-one. Well, the fact it doesn't have any of these items means that this is a one-to-one function, which means it has an inverse.
Okay.
Now, to find an inverse, I'm going to put a note up here. The function must be one-to-one. Of course, it has to be a function also.
Mm-hmm.
If it's not one-to-one, then you shouldn't even try to find the inverse.
What if there's like a line that's going from like the y the y-axis restricted from like the y-axis right, would the inverse then be the going from the y-axis left, or just be considered a line, like not a function?
You mean if your line was the y-axis?
Yeah, but if it was restricted from like a certain point, would the inverse just be like, okay, the restrictions are flipped?
No, in that particular case, since it's actually a vertical line, it would not be one-to-one even if you put restrictions on it.
Oh, okay.
And the reason why is there's something that I'm not sure if there's any problems dealing with it, but there's something called a remember the vertical line test?
Oh, yeah.
There's a horizontal line test. If it fails a horizontal line test, then it's not one-to-one.
Okay.
So
Okay.
that would be the oddball exception to the exception I just mentioned.
Okay. Sorry.
Now, step one is replace f of x with y. Step two, interchange x and y, swap them. So where the x is, you put a y. Where the y is, you put an x. Step three, solve for y. Step four, replace y with your inverse notation. It looks like f to the negative 1 power. That's the inverse of f. And step 5, if necessary, use the graph to help make the inverse one-to-one. So those are going to be our steps we'll go through.
Good.
So for this one, step 1, replace f of x with y. So we got y is equal to 6x minus 2. Step 2, interchange x and y. So we got x is equal to 6y minus 2. Now step 3 is solve for y. There could be all kinds of different techniques to solve for y. In this case, I'm going to take the negative 2, move it to the left side. You move anything across your equals, your sign changes. And then I'm going to divide everything by 6. Remember there's an invisible 1 before the x, so that's 1 6x plus 2 6 equals 6 over 6y. So we got 1 6x plus 1/3 is equal to y.
Okay.
Now step 4 is replace y with your inverse notation. So the inverse of f is equal to 1 6x plus 1/3.
Okay.
Now to verify these graphically, you just find its inverse, check your answers algebraically and graphically. Let's talk about the algebraically first. Determine if there are algebraically inverses, the original function what you just found. You find the composition of the two. So we'll find the composition of f and the inverse. Which, remember evaluating the function, we got f of something, we're going to go to our f of x, and everywhere I have a parenthesis, or an x, I'll put in a set of parentheses. Now whatever is inside this parentheses automatically is put in here. So you put the inverse in there. Well, the inverse was equal to 1 6x plus 1/3. So then 6 times 1 6 is 1, so that's 1x or x. 6 times 1/3 is 6/3 or 2. 2 minus 2 will drop away, and that gives us x. And that's what it should give us.
Okay, is it possible also just like plug in a point, just be like, okay, x is 0, and then evaluate?
Probably most of the time you can get by with that. But just because it works for the first like 20 points doesn't mean it would always work.
Okay. All right, so evaluate the function.
Yeah, this is on the safe side to do that. From a practical standpoint, yeah, you're probably fine there.
Alright.
Now, you have to find it both ways, because both ways have to give you the x. So in this way, I'll find the inverse of f, and then of f. So our inverse is equal to this down here. So I'll go through, and I'll replace the x with parentheses. Now whatever is inside the parentheses right here is automatically what you put in here, so we'll put f in there. But f is equal to 6x minus 2. Plus 1/3. 6 times 6, or 1/6 times 6 gives us 1, so that's 1x or x. 1/6 times negative 2 gives us negative 2/6, plus 1/3. And negative 2/6 is negative 1/3, and plus 1/3 cancels and gives us x. So that's how you check it algebraically. Now graphically, I think you've played with this app before.
Right. Yeah, I played it. There's another one.
Wabbit?
It's not Wabbit. No. It's it's kind of it's a web app, so it's not as powerful, I think, as this app.
Oh, okay. But if I were to graph both of them on the same display, what I'd see, 6x minus 2, and then on y2 I'm going to put 1/6x plus 1/3, and then graph. Now these should be symmetric to the line y is equal to x. So if I come here and I put x down here, but I'm specifically going to go over to the far left, this calculator allows you to make it a thick line. And then if I press graph.
Okay, yeah, it's symmetrical.
Yeah, so it's symmetric to that line y is equal to x. So that's what they're asking when it's verified graphically.
Okay.
Is that good on that problem?
Yeah, thank you.
Now, did you want to see 1 through 11 or 1 and 11?
Just 1 and 11.
Oh, okay. I saw the plus there, and I didn't know if that should have been a through 11.
Oh, jeez.
Okay, now this one's one of our oddball cases because it's got that x squared that I referred to.
Okay.
So we got f of x is equal to x squared minus 10x. And x is greater than or equal to 5. Okay. Now, they say show that the given function is 1 to 1. We're going to need the graph eventually anyway, and the graph actually shows it. If I were to graph this, remember your vertex is negative b over 2a and f of negative b over 2a. So we'd have b is negative 10. So I have negative 10 over 2 times a. A is whatever's in front of our x squared. Negative gives us positive, so we'd have 10 over 2, or we'd have 5. And then we plug that into our function. Is that good on that?
Just wonder, for the vertex function when it's in it's almost just like standard form, almost, right? I mean,
I could also complete the square and put it in standard form. Do you want to see that way?
Actually, do you think it's easier like negative HK, or do you think it's easier to just do minus B over 2A?
I think it's easier this way, but some people like the standard form. Which way do you like?
Yeah, could you show me the standard form also?
Sure. Now to plug 5 in, we'd plug 5 into our original function, and I'll go ahead and actually put it in here. So we'd have 5 squared minus 10 times 5, which is 25 minus 50, which gives us negative 25.
Okay.
Okay, now our standard form, we've got x squared minus 10x. We want to complete the square. There's no number in front of the x squared, so we don't have to factor that out. But we want to complete the square, so I take the number before the x, which is negative 10, times a half and square it,
Okay.
which gives us negative 5 squared, or 25.
Okay.
And then we both added and subtracted. So I got x squared minus 10x plus 25 minus 25.
Okay.
Now you have to be careful to group these first three together and then the last one by itself.
Right. So x minus 5 squared minus 25.
Right.
Okay.
And then for your vertex, it's always going to be the opposite sign of this. So your h is 5, and k is going to equal to negative 25.
Okay. Okay.
So then it gives you your same vertex. Now you're right. If the condition occurs at where this x value is, it's only looking at 1/2 of the parabola.
Mm-hmm.
And we'll see that. I'll graph that here in a little bit. But the fact that that 5 matches, that pretty well tells us it's 1-to-1.
Okay. All right. Well, what condition would make that not true? Like,
Probably if it said x is greater than or equal to 0.
Okay.
And if you came up with 5 here, then that's definitely potentially something wrong.
Okay.
Now,
All right. Because okay.
yeah. Now, if it's x is greater than or equal to 6, it would actually work out in this case, I believe. I'd have to look at the graph and see. But. Now, step 1. Replace f of x with y. This problem might actually be easier if we use with standard form to find the inverse. Step 2, interchange x and y. So we got x is equal to y squared minus 10y. Step 3 is to solve for y. And in order to solve for y, we have to complete the square. Same idea. We take the number before our y, which is negative 10, multiply by half and square it. So that gives us negative 5 squared, or 25. But we're going to add that to both sides. So I got x plus 25 is equal to y squared minus 10y plus 25. So I got x plus 25 is equal to, and this factors as y minus 5 squared. Reason why is whatever number's right here, right before you squared, is always what goes right here, sign included.
Okay.
Now we got something squared equal to something else. So we can solve this using the square root property. Square root property says if you got something squared equal to something else, you drop the squared and you put a plus or minus square root around the other side. Y minus 5. Now I'll take the negative 5 over. It becomes a positive 5. And then step 4. We want to put our notation in there.
Do f of minus 1 for x to the power, or
Right.
inverse. How do you say that, Professor? Is it f inverse of f?
Inverse of f. Yeah.
Okay.
Now,
Is this possible? I mean, if it's plus because it's restricted by x is greater than or equal to 5. So it
right.
looks
That's
like,
the only reason why we can do it. Because there we have to do step 5. If necessary, use a graph to make the inverse 1-to-1. Because, yeah, you're right. We said we can't have a plus or minus for a 1-to-1 function. So let's look at the graph on this. And x squared minus 10x. We had x is greater than or equal to 5. I'll shut my window. They're mowing grass next door.
Oh, jeez.
We're doing something.
Must be not, you have nice weather down there in Kansas.
Oh, yeah. It's a little warm, actually.
Oh, jeez.
Is it cold where you are?
Yeah, it's about 38 degrees this morning. Or
Oh, wow.
30. I think it's freezing. I'm in Seoul. It's chilly.
Okay, so this would be 5, 10, 15, so forth. And these will go by 5s too. So -5, -10, -15, -20, -25.
Hmm.
We said this is our vertex, so 5, -25 would be right here. And we're keeping the right side of it. Now, getting the exact graph really isn't that important, but you could find the x-intercept if you wanted to.
Hmm.
For the x-intercept, remember we plug 0 in for y. That's not very easy
Right.
there.
Yeah.
Let me look at the standard form.
Could you just factor out, or you could just factor out x, right? Or set y to 0, factor out x? Or
I think it'd be,
well,
well, see, if I chose this one right here, if I plug 0 in for y, it wouldn't be
Yeah.
too bad.
Also for x squared, 10 squared is 100. 10
Oh,
times
I see what
10
you're
is
saying.
100.
Oh, yeah, that would be easy up there, wouldn't it? It'd give you
Yeah.
10. It's even easier to choose the original one. Yeah. So, I know it's going through 10. It has a curve there. So it looks like that. Now I know the inverse. Give the 4 graphing skills here. I know the inverse should be symmetric to that. Now this point here is 5, -25. So my inverse will be -25, 5.
Oh, okay.
The points swap.
Oh, all right.
So if I've drawn it correctly, -25, 5 would be there. And then if I sketched it, that should be going up, not down.
Mhm.
That would be our inverse.
Okay.
Now this is what we want. So that's what we want. That's not what we got, but that's what we want.
Mhm.
What we got was this plus or minus.
Right.
Well, think about what my y values are equal here. The lowest is 5. And then it's slowly going up forever.
Mhm.
There's no way I'm going to have 5 minus something. So to make this one 1-to-1, we simply drop the minus version, the negative version.
Oh, okay. I
Yep.
see. It's never gonna go. It's never gonna go down. It's always going to go up.
Always going to go up. That's why it's important for me to actually draw it so it's going up.
Okay.
I started going down there. It's like,
Okay. All right, I get it.
yeah. So when you got a plus or minus, you're going to look at the graph and use it to help you figure out whether you drop the plus or the minus.
But will we have to do that regularly? You think is that like a normal occurrence when solving these problems?
It's
Or
a
is it-
normal occurrence when you got an x squared. You almost, I'd say you always have a plus or minus, and you'll have to graph it to figure out which one of those to drop.
Okay.
Now they'll also oftentimes put the domain on here, and that's just where the x values are valid. So this would be where x is greater than or equal to -25. Now they're not
All right.
they're not putting that on there to make it 1-to-1. Us dropping either the plus or minus is what makes it 1-to-1. They're putting
Right.
that on there to specify the domain.
Right, because of the square root.
Right. Does that make sense how to find the inverse?
Yeah, yeah, totally. Yep. I think that's. I think that's all my questions for today.
Is that all your questions?
Yeah. Thanks, Professor.
Yeah, and like I say, I'll be on here every Sunday, so answer questions.
All right, cool. Professor, I'm curious. What other like computer? You teach computer science as well, right? You teach like C sharp, or I don't know what that's called.
This semester, I'm teaching a C-sharp programming class and a introduction to computer science, which is learning some HTML and JavaScript at the same time.
Oh, okay, cool. I downloaded that Visual Basic Studio just for kind of kicks, and I was like, wow, this is. I have no idea about the syntax, but I saw that you also had some videos, so I'm gonna when some free time. I'm gonna check that out. Just kind of see if I can get like a simple app, running
Right.
on it. Is that for anything specific? Like, or I mean, is that for web apps or databases or?
Um, it's you can use it for databases. You can use it for web apps. I don't know if I can actually remember the where I put it at, but slash add it. No, I'm not gonna be able to remember it. I created one in C Sharp. No, I created one in C Sharp just to see how to create an app that I could run on my website.
Oh, cool. Okay.
It doesn't do anything exciting. It says just add two numbers together.
All right. All right. That's a good, really good. Being able to plug in like programming languages into a website is pretty cool.
Right. Are you thinking about going into computers?
Yeah, I majored in English literature, and I'm teaching here in South Korea for the past couple of years. But I'm trying to transition into more computer-based stuff. So it's the plan, at least.
The more you program, the better you get. I'll tell people that just do as much, like you say, just download it and just start programming whatever you can think of. Program the vertex formula and so forth.
Oh, it's a good idea. Okay. All right, yeah. I'm thinking that the computer science also on the university university
okay.
just kind of it's an interesting platform. How long have you been involved with UOP?
This is a second class that I've taught for
him. What's your opinion? You seem to know quite a bit about, or it seems like you have some experience with the online learning realm. You find it to be somewhat, I mean, is it on par with other programs you've seen, or is it kind of like, is there, I mean, it's an interesting format. That's the first time.
I think it works very well with math, but to be honest, I don't know about the computers. I haven't seen any computer class. A completely text-based computer class, I think, would be a very challenging online. But maybe I'm wrong. I don't know.
Yeah, it's I think, yeah, I agree. I think that like kind of team building or like teamwork exercises would be really helpful. I think with computer stuff.
Yeah, one of the videos I created last night answering or helping a student figure out what's wrong with their web page, their HTML/JavaScript. It took me 25 minutes, and I was trying to not to use the debugging tools of the browser. But it took me 25 minutes to figure out, and it had to do with some invisible characters in the file. It took me forever.
Invisible characters?
Yeah. If I'd went into like a hex editor, I would have been able to see them, but just in Notepad, I couldn't see them.
Like non-ASCII characters or something, or like
right.
Oh,
I'm not even sure how I put them in there in the first place, or maybe he put them in there. It was different.
Well, that's it's wild. It's wild.
I didn't notice it until I think I was doing my right arrow key to go over, and when I did the right arrow key, it didn't appear to move. And I thought, well, that's interesting. And then I did it again; it wasn't moving. It's like, well, it's thinking there's something there.
Oh man. Very cool. Oh, thanks again, Professor, for
You're welcome.
having these. I'll see you next week, I suppose.
Okay, that sounds good.